Okay, so you guys just read about the location principle. We're going to go over some key terms from that. 4.2, we are analyzing graphs of polynomial functions. And so our goal with that is to approximate zeros by graphing polynomial functions. We're going to do that today, and we are also going to find the extrema. That word extrema, do we remember what that means, what that entails? Yeah, good. So that's going to be your relative maxima and the relative minima. So that's the plural for maximums and minimums. And you can have multiple. Okay, so the relative maxima, the relative minima, we're going to be finding multiples of those. Okay, so remember that when we had parabolas, you don't have to write this down. I'm just going to show you this for reference. When we were working with parabolas, we had one minimum and one maximum. Now that we're going to be working with polynomial functions that could have a greater power than 2, you're going to have shapes like this. You're going to have shapes like this. So there might be one relative min, or there could be 2. There might be one relative max, or if this was flipped upside down, there could be 2. Okay, so it's going to be dependent on your graph. So the location principle is based on something we've talked about before. So it says, suppose y equals f of x. It's called the location principle. Suppose that represents a polynomial function and a and b are 2 real numbers such that, and then it says f of a is less than 0 and f of b is greater than 0. Okay, so I always had a hard time understanding what these boxes say, so that's why I want us to talk about them together so we understand what they're trying to tell us. If you have f of a, okay, that is an output when you plug in what? What would the input value of f of a be? What do you guys think? Well, if it was f of x, what would the input be? If it was f of x, what would you be plugging in? No. That your y is your f of x. So if you just had f of x, right, that's your output value, you'd have something like this, x cubed plus x, right? You would be plugging in your input. So x is your input, what's your output? Just your f of x, right? So if you have f of x, your x is your input, right, in your equation, f of x is your output. So they tell you you have a and b, so if you have f of a, that's just your output value. So that's just your y value. So if they're telling you that f of a is less than 0, they're just telling you that this output value is what? What type of value? Negative. Yeah, good. So if you plug a into the function, right, if y equals f of x, then that would be a negative, and then they're saying f of b is greater than 0, so that would be a positive. Do you guys remember a time where we looked at the outputs and saw if it went from negative to positive? What do we call it when it goes from negative to positive? What happens? The negative or the positive are just our signs. Your signs are going to change. When you have signs that change, I think we need a little memory jog. Remember we had these big tables like this? And we'd have like 0, 1, 2, 3, 4, 5. There was 1, -3, -5, -6, 7, and 8. Do you guys remember what we had to find with those? Yeah, we looked to see where the signs changed from positive to negative, and then do you guys remember what that meant? Yeah, the zeros occurred where? Yeah, so then we'd say, oh, the zeros occurred between 0 and 1. Where would the other 0 occur? Yeah, good. Okay, so that's exactly what this is telling you, is that these zeros are going to happen in between your sign change. So the location principle is something that we've already talked about before, we just didn't know what it was called. So the zeros occur between the sign changes. And it's only the sign changes in the output values. Okay, so the zeros occur between the sign changes in your outputs. Put my S in there. The zeros occur between the sign changes in the outputs. Okay, and then this also says the function has at least one real zero between A and B. So that's exactly what this is telling you. If one is negative and one is positive, then the function has at least one real zero between those two values. Okay, A and B are your input values. Those are similar to your X values. And then one thing we also have to know is all the different ways to say zero, because they're going to ask you for the same thing in many different ways. So if they're asking you for a zero, we have to know that means it's an x-intercept. So a zero is an x-intercept. Do you guys remember another word for it? Starts with an R. A root. Okay, and really sometimes they'll just ask you to find the solutions. So the zero, the x-intercept, the root, the solutions, okay, all of those are interchangeable words. Okay, so I put a note on here that we're using different directions from those that are in the textbook. That's because the textbook asks you to do a lot more things than what I'm going to ask you to do. Okay, there's a lot of comparisons that they use, and we're not going to compare. We're going to focus on the graph. So you just have to complete your homework according to the directions in the notes. So what I did is I just aligned each example to the one in the textbook. So for example 1 in your textbook, when we do this tomorrow, you are going to follow these same instructions, okay? For example 2, you're going to be following those same instructions. So make sure that you pay attention to that tomorrow, and I'll give you another reminder. And then we're going to do a lot of rounding today, so we're going to round answers to the nearest thousandth. Okay, we're going to round answers to the nearest thousandth. And we'll do that consistently throughout this section. Okay, so we are going to use a table to graph the function. And there was a typo, so we fix it for me. I'm sorry, I hate making typos, but such is life. Yeah, we just missed the I and the T, just not, little jumble there. And then you're going to find the zeros using a graphing calculator. Now we're also going to use our graphing calculator to help us with the table. Okay, so the first thing we're going to do is we're going to plug that into our graphing calculator. So we can have this out, please. And we're going to plug that in to our y equals. Okay, so we have 2x to the 4th, so go to y equals 2x to the 4th. What happened? Oh, and then plus x cubed plus minus 2. Okay, and then you can hit graph. And then remember, if you're somewhere else, then you can go to Zoom and then go to 6, which is the standard, and then you can see if it fits in that template. Okay, so then And from there, is our graph going to fit in the standard window, that 10 by 10? Okay, great. So then what we're going to do is we're going to create our table. So your graph should look like this. Okay, and then we're going to go to the table on our graphing calculator. Okay, and then, so if you're starting at 0 and you scroll down, okay, you want to look for those sign changes. So we're not going to have to graph the negative 106, but the negative 210, we should graph that. The negative 1, negative 4, the 0, negative 2. Oh, now do you see the 0 and the 1 are at the same thing, at the same place? Look at what our graph looked like. Are there any straight lines in that? No, there's no constant term. Okay, so this is like a small little curve there. So it's going to be helpful for us to find what's in between them. Do you guys remember how to change that on your table set? So you can go to second table set, and then if you want, you can either choose to go by halves, or you could start at a half. Okay, so at positive 1/2, I'm at negative 2.5. So that's going to help me create that curve there. Okay, so if you notice that 2 points next to each other are the same, there's not going to be a flat part of these. They're all going to be curved. Okay, so we got to make sure that we do that. And then at 2, I'm at 26. So that one is kind of big. So you might want to try the 1.5, which is at 4.75. And then you can decide if you want to put that 226 on there. But you want to make sure that you get your sign changes in there. There's no other sign changes. If you look at this, it just keeps going up to infinity. And then in the negative direction, this is just going up to infinity. Okay, so when you're trying to figure out what your scale is going to be, we have to make sure it at least goes up to 10, down to negative 4. Okay, and then if you wanted to go to 26, you can base your scale that way. Okay, so if I have negative 4 is my lowest one. So I made this negative 4, negative 3, negative 2, negative 1. I could make this 0. Might still have room to get to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and I know some of you might be working ahead of me. If you are, when you connect your points, make sure you curve them. I'm going to give you some tricks to help you make a good looking graph, because that is not always an easy thing to do, especially when you have values that are this spread out and it is a curve. Okay, so based on the location principle, I know that between 10 and negative 4, because there's a sign change, that in between these, it's going to cross the x-axis. You're going to have a 0 between those. Okay, so it is going to have to cross that. There's another sign change from negative 2 to 4.75. So this is going to be another 0. It's going to happen in between here and in between those two. Okay, so we are going to find the zeros together, and we'll keep that in mind. So at negative 2, I'm at 10. Okay, and then at 0, I'm at negative 2. And so this, if I didn't graph that 0.5, I would have these two. They are never going to cross at a straight line like that. So thankfully we did this and we got the 2.5. And if you guys want, well, I'll graph the other one. So at 1 we have negative 2, which I graphed, and then at 1.5 we have 4.75 here. This might be hard to see on my graph, but what I'm going to do first is I'm going to make my curve. And guys, you have a model for what it should look like here, right? So we know this has to be curved. So I find it easier to do like my curve like this. So you're going to curve this through like that. So I do that part of my W. And then it goes straight through that point, and then you're just going to continue going up. It's okay if it's, I know sometimes it can get a little shaky when you're going up for that long and it's steep, right? Okay, so for this one, we're going up and we're curving it there. And then if you need to go back through, because that's going to make it look a little nicer, that is fine. Okay, and then the more you practice it, the better it's going to look. Okay, so you should have something similar than what is on your graph. Sorry, that's blurry. And then if you remember how to find the zeros, which I think some of you do, you can go ahead and find those. That is going to be the next step. Okay, so to find the zeros, that means you're going to find your x-intercept. Okay, so to do that, you guys press the second button and trace, because that takes you to the calculations. So second, trace, and then we are going to use the one that says 0. It is number 2. Okay, you can just press number 2 and it will take you there. And there's our good old buddy left bound. So the goal is to get as close as possible to the x-intercept, then use the left bound and the right bound. When you are doing the left bound and the right bound, one of them should be below the x-axis and one of them should be above the x-axis, because you have to show the calculator your sign changes. So we've been talking about sign changes a lot today. Okay, so I want you to try to find the left bound and your right bound. Right, and it doesn't matter which one you do first. So we're going to get as close as possible. Mine looks good there. So I'm going to go one to the left, press enter. I'm going to go back to where I think my x-intercept is, press right. When they ask you to guess, you can technically stay there. I like to go back to my guess. And then you should have this value when y is 0. So your x value is negative 1.64. It says 0.6 ... And this is when your y value equals 0. So if you're rounding this to the nearest thousand, how many places after the decimal back? The nearest thousand. 3. Yep. So what we do, I always underline it, and then I look at the one behind it. So it's x equals negative 1.641. Okay, so this is one of your zeros. All right, and then I'm going to give you guys a moment to find your second one. And then once you've done that, if you want to plug in the second graph. Don't want you working ahead of me. I'm going to help you with your windows and what you need to see, okay? And then for the second 0, you got 1.2382. And again, it says when y equals 0. Sometimes you might have a scientific notation there, like it might say something e to the negative 12. Remember that that rounds to 0. So that's something that we've seen before. Okay, and then here is your second 0. All right, now example 2 is very similar, except now we're not finding the zeros. What are we going to be finding? Yep, your relative max and min. So we're still using the table to graph the function. Then you're going to estimate the relative maxima and relative minima. And then it says, and state the x-coordinates at which they occur. So based on those directions, we are going to be writing these out in a different way than we have before. Because we have found our max and mins before, okay? And we have to understand that the maxima and the minima are going to be your y-coordinates. Okay, these are the y-coordinates of your max and min. So while we're going to use our graphing calculator to find those like we've done before, the way that we are writing out our answers is going to be a little bit different. So your relative max and min are going to have this format. Okay, you are going to say the y-coordinate, and I'm going to put this in like a blank space because that's what you're going to put there, at x equals, and then you're going to find the x value. Okay, so this is how you're going to write it out. You're going to find the y-coordinate, then you're going to write at x equals, and you're going to find that x-coordinate. Okay? All right, so let's graph this. So we're going to plug this in. We have 2x to the third plus 10x squared plus x minus 2. Okay, now if you graph that, you cannot see the full graph. It's important that you see all the maxima and the minima. So what we're going to do is adjust this. So we've talked previously about using the zoom out feature or sometimes the zoom fit. But for something like this where you can see most of the graph, the only thing you can't see is this maximum. We're just going to adjust the window. Okay, and what part of the window am I going to adjust? The x's or the y's? The y's, I have to adjust the y max. And then we can just bring it up to 40. If you want to change the scale, you can. You could go by like 2's. If you don't change the scale, you'll see like all the tick marks are really close to each other. Okay, and that's a good window. So now I can see that full graph there. And so I'm going to go to my table. Okay, I'm not going to tell you how many points exactly to have in your table. You should have at least 5, but you're going to need to, sorry, I'm still going by halves. I want to go by ones. Okay, but you have to do enough to get your sign changes in there. So I'm at -5, I have -7, -80. All those keep going down to negative infinity. I have to make sure I have both of the sign changes in there, or however many there are. And so I'm going to put in -5, -7. And then it goes to -4, 26. -3, 31, -2, 20, and I'm going to keep going until I see my other sign change. -1 and 5, 0, -2. So I have another sign change, and then look, another one right next to it. 1, 11, and then the 256. I'm not going to have to include that because now they're just going up to infinity. Okay, so you can decide what you want your scale to be, but you have to make sure that you go all the way up to 31, and you have to go down to -7. So 2 is not going to be enough based on how many boxes we have here. When you're doing this on graph paper, if you wanted to do by 2, you absolutely could and have the 15. But you should use either 3 or 4. You can decide which one you want to use. Okay, and if you use 4, then you'd have to have -8, -4, 0. If I have a limited space, that I usually count backwards to find what that is. So this would be 4, 8, 12, 16, 20, 24, 28, 32. Okay, and like I said, you can decide if you want to go by 3s, you can absolutely do that. Now with the x's, I just have to go by 1s. So your y scale and your x scale can be different from each other. That's okay. And then we're going to plot our points. So at -5, I'm at -7, so that's approximately here. At -4, I'm up at 26, so if this is 28, I'm at 26. At -3, I'm at 31. So that's very close to 32. At -2, I'm at 20. And then this might be a good place too to do like your curve. Okay, and then at -1, we're at -5. At 0, we're at -2. At 1, we're at 11. So again, sometimes what I do is I do this curve first. Okay, and then you should have your graph close together. And then once you do the curves, you are ready to find your relative minima and maxima. So we're going to use the calc feature again. To do that, you hit the second trace button, and then you're going to find your min and max. Now, sometimes there's more than one. This one has one of each, but there could be 2 mins and 1 max. So you have to find however many there are. Okay, so we're going to go to second, calc. It doesn't matter which one you find first. If you find the maximum first, again, you're going to try to get right in the center, and then you're just going to go a couple to the left and a couple to the right. You're telling the calculator, hey, in between these two, find the highest point, and so that's what it does. So the way that we're going to write this, we're going to label what it is. So I found the max first. Okay, so the maximum is the y value. So we're going to do the y coordinate, which is 31.72, and then it's 8, 9. So that's going to be bumped up to a 9. And then we're going to find the x value. So that's going to be -3.28, and then it's a 2 and then a 5, so that's going to round up to 3. Okay, so I want you to find the relative min. Okay, I want you to find your relative min from that. and I want you to practice rounding to make sure we got that. Okay, and then just double check, make sure that you're rounding it correctly. So you're always writing your y coordinate first. So your relative min should be negative 2.025 when you keep it the same because of that last number. So it's always the y value at, and then this is negative 0.05, and then that 7 pushes that 0 up to a 1. Okay, so this is going to be the format for example 2. Your relative max and your relative min. All right, and then when you're ready, you can flip that over to the next page. Okay, so we're going to talk today about polynomial regression. You likely did linear regression in Algebra 1, whether you remember it or not, because you did scatter plots. Do you guys remember doing scatter plots? Like you were given data points and you had to plot them. There were a bunch of them, and maybe it looked like that, like all the data points. And then what you had to do is you had to find a line of best fit that went through the data, like that. Does that ring a bell? Okay, and you probably only did it with linear functions because that was the main thing that you guys did. But now we can have functions that have points that are all over the place, and then what we have to do is we have to find this function that fits them. So we're going to learn about new types of regression. So linear is one of them. There's also quadratic, cubic, and quartic, and those are the ones that we're going to talk about today. So polynomial regression, the 4 types we're going to focus on are linear, and each of these have nicknames. So if it is linear, on your graphing calculator, you're going to see this as linreg, linear regression. If it is quadratic, it's called quadreg. If it is cubic, you would think it would just be called cubereg, but it's not. It's cubic reg. And then quartic is quartreg. So these are going to be the 4 that we're working with. And we're going to use our graphing calculator to help us find these polynomials. That's why it's really important that you have it. Okay, so we're going to be using it a lot today and tomorrow and the rest of the week. Okay, so when you are finding these on your graphing calculator, you're going to hit the stat key. And then once you hit the stat key, a menu is going to pop up. Okay, so once you hit stat, you have this menu. You are going to arrow over to the calc section. And there's so many fun things in the calc section. We are going to focus on the regs. So if you look here, you have linreg, you have quadreg, cubic reg, quart reg. These are the 4 that we're going to deal with. We're not going to do with this linreg, where the B is with the X, so don't worry about that. We're not going to do any of the other ones down there. Right? So what we are going to have to find when we're using linear regression is we're going to have to find what's called the correlation coefficient. Correlation coefficient. And the correlation coefficient is R squared. Okay, so if it's correlation, it correlates to something, right? So it's a relationship between them. Okay, we want to see how strong the data is correlated to our line. So that correlation coefficient, that's what it tells you. How close the data fits the line. Okay, because you can have some really strong regression lines, but you can also have some really weak lines. So what you're looking for is how close this number is to 1. You're looking to see how close it is to the number 1. The closer it is to 1, the better the fit. Now, sometimes 2 functions have the same R squared value. Sometimes they both have an R squared value of 1, and if that happens, you have to check to make sure that the A value is not 0. Okay, and by that, we mean if you have a function, right, we talked about yesterday how they have like ax to the 5th plus bx to the 4th plus cx cubed plus ... If your A value was 0, if this was a 0, what would happen to this? Not all of them, but this one would, right? 0 times x to the 5th, this would just be 0. This would go away, and what would your degree be now? It'd be 4. Okay, so if the A value is 0, then it's not going to be that function. It's going to be the one, the next one down from it. So what we're going to do today is we're going to learn how to enter data into our calculator. Have any of you done that before, entered data into the calculator? You guys have? Okay, so some of you might be familiar. We have a table that shows the opening value of a stock on the first day of trading in various years. What we're going to do is make a scatter plot and curve of best fit. We're going to do this on the calculator though, because we want to see what the trend is over the given time period. And then we are going to use the regression equation to estimate the value on the first day of trading in the year 2000. And just like we did before, we are going to be rounding coefficients of your regression equation to the nearest thousandth place. So we're going to keep that consistent there. Now, when you are entering data to find these equations, when they give you the years, it is best for you to let your x value equal the number of years since the starting value. Okay, if not, you're going to get some very, very high values because 1994 is really like 1,994. So if you let x equal the number of years since 94, then your x value is going to be 0, then 1, then 2, and in this column, do you guys see how this is the year column and this is the year column? So this would be year 3, year 4, year 5. Okay, so our x values are going to be the years. There's 2 columns like that. And then the price is going to be our output, which is similar to our y values. Okay, so I'm going to show you how to access the list in your calculator. press the stat button. Okay, and then you are going to hit enter. In the list 1, you are going to put the X values. In list 2, you are going to put the Y values. Okay, so list 1, you're going to put the X values. In list 2, you are going to put the Y values. Okay, so we're going to do that right now together. Okay, so find your stat button. It's right here. And then after stat, you just press enter. Oopsies. So you guys probably have clear ones, right? Do any of you not have clear values? I will show you how to clear it. So in list 1, we're going to put our X value. So we're going to start with 0, and then you press enter. 1, enter. 2, enter. 3, 4, and 5. Then we're going to enter over to list 2, and we're going to put our Y values into the list. Right, now once you have those entered into your list, what we have to do is we have to find the R squared values for all of our linear regressions. Okay, so this is step 1 where you enter everything into the list. For step 2, you're going to find your R squared values. And in order to see them, you have to turn your diagnostic on. And I'm going to show you how to do that. I'm going to show you 2 ways how to do that. Okay, so if you have a calculator that is similar to mine, if you press the mode button right here, mode, okay, and if you go down to here where it says stat diagnostics, it's towards the bottom. Yours probably is already selected to off. So we're just going to highlight on. And easy peasy lemon squeezy. That's it for that. Okay. And then if you don't have this type of calculator, there's another way to turn it on. You are going to go to your catalog. Okay, so if you don't have the like the CE plus, that's okay. So you're going to go to second, and then I want you to press 0. Okay, so second 0, so that you're here. Okay, and then just raise your hand if you can't get to the catalog when it's second 0. Okay, and then what you can do is you can scroll down to diagnostic on, but if you tell your calculator that you want to start at the D's for diagnostic, you can just go to alpha and then go to D. Oh, just kidding. Oh, it should be alpha D. Yeah, hit the alpha and then the D and it should take you there. If not, you can scroll and then you should get to a diagnostic on. So I want you to scroll there. And then you just press enter, and you press enter again, and it'll say done. Okay, so you need to have this on in order to see it. Oh, you don't have to do that if you already have that. Yeah, if you already turned it on from the mode, you don't have to do the catalog. Okay? So you'll know that you have it on in this next step. What I'm going to do today is I'm going to show you how to find the linear regression. So we're going to go to stat. We're going to arrow over to calc. And then we're going to go down to linreg. Okay? So to find don't worry, I'll show you again. Okay, so to find this, you're going to go to stat. You're going to arrow over to calc, and you're going to find the regression that you want. Okay, so we're going to start with the linreg, and we're going to write what our R squared value is. Okay, so we're going to go to stat, going to arrow over to calc, and then we're going to go to number 4. Press enter. Now again, most of you are going to have a screen like this where you just have to press enter, enter, enter. Okay, and then once you get here, you should have an R squared value. I want you to write it down and round it to the nearest 1,000. Okay, I want you to write it down and then round to the nearest 1,000. And then I want you to do the same thing with quad reg, cubic reg, and quart reg. And all I want you to do is find that R squared. Okay, and it does need to be the R squared, so not the R. Okay, so for the linreg, you should have 0.224. And now I want you to go back, do stat, arrow over to calc, do the quad. Okay, so find the quad reg, and I'm going to come around and I'm going to help you. But I want you to have the R squared value for the quad, cubic, and the quart. Did I write quad reg again? Oh no, I did. I wrote. Okay, so that's all I want you to do.